Okay, we're going to do our S13 review on integral calculus. So here they give you a function, x cubed plus 4x squared plus 4. Okay, that's this function right here. And it's the shaded region bounded by -3 and +2. So we're finding this area right here. Okay, so since my lower boundary is -3 and my upper boundary is 2, that's going, they're asking me to write an integral, we have to write the integral symbol, which is this long stretched out S, and beginning at -3, so we're going to have a -3 down here, ending at 2, so we have to have a 2 here, and then I write my function, and we have to write dx because that tells us what variable that we are integrating on. Okay, if you don't write the dx, if you're missing parts of these, you don't get partial credit. You have to write the integral, you have to write your upper and lower bounds, you have to write the dx, you have to write the function. Okay, so now they want you to find the area. In this example, I want you to show all the steps of the fundamental theorem. So the step 1 is I wrote the antiderivative of x cubed, and we get x to the 4th. If it's x to the 4th, we have to have the coefficient of 1/4. Antiderivative of 4x squared is going to be, the power is going to increase to x cubed, and then this is going to be 4/3 x cubed. The antiderivative of 4 is going to give me 4x. And since my lower boundary is -3 and the upper boundary is 2, I'm doing the antiderivative with putting 2 in place of x, and the antiderivative putting -3 in place of x, and we subtract those. So here I've put in 2 in place of x, here I've put in -3 in place of x, and then we get our final answer. You might want to hit pause if you need to. Now, for 1c, they said, okay, now you've got a triangle and it has the same area as the region up above. Okay, so, and you know these points, 0, a, 4, 6, and a, 0. What does a here have to be in order for the triangle to have the same area as this over here? Well, you know the triangle is 1/2 base times height, right? Here's my base. From here to here is the length a. The height from here to here has a length of 6, right? And we just calculated earlier that the area was 50.41. So now my only variable I have left is the base, a. So I multiply 2 on both sides of the equation, we divide both sides by 6 on each side, and then I end up with 16.8. Okay, hit pause if you need to. Okay, next page. All right. The rate of change of height from a ball horizontally with the ground is measured in meters and t seconds after it's been thrown. Okay, so they've given you my velocity of the ball that's being thrown, and the height of the ball at time 0 is 1.2 meters. Find an expression of the height of the ball. So to figure out the expression of the height, we have to take the antiderivative of our velocity function, because the change of height with respect to time is velocity. Okay, this here is velocity. Okay, so to figure out the function for the height, I have to take the antiderivative of my velocity function. So the antiderivative of 28.1 minus 9.8 t is going to give me 28.1 t minus 9.8. This is going to become t squared, and so we have to divide by 2. Okay, and then plus c. And now we're going to calculate and figure out the value of c. We know that when t is 0, I'm going to replace t with 0, we know that our height is going to be 1.2. So I'm going to replace height with 1.2, and that with 0 and that with 0. So if those are zeros, that's going to cancel out, right? And if that cancels out, we're left with c equals 1.2. And there is my function. Okay, so now I want to find out the height of the ball when it hits the ground. So if I want to find out the height when it hits the ground, that means I need to figure out the 0. Okay, so I type in my function. 28.1x minus 4.9x squared plus 1.2. Okay, I can hit graph, and I'm going to see my function. Okay, now look, it went way too high up, so I don't know where the top of it is. I'm going to go change the window. I'm going to change the Y max to something bigger, 50. I'm just making this up. Let's see if 50 was high enough. Oh, it was. Good guess. Okay, so there's my graph, and I want to figure out the 0. The 0, this point right here, that's when it hits the ground, when the height is 0. So to figure this out, I have to do second trace, and then I'm going to choose 2 for 0, enter. And now I have to figure out the left bound, so I need to go to the left side of where my pen is pointing. So I'm going to have to hit the right arrow here. So see on my graph how it's changing over here. The right arrow gets me closer to it, and I'm going to hit enter. And now it says right bound. I need to go to the right side of where my pen is pointing, so I'm going to hit the right arrow. It looks like I'm to the right now of it. Hit enter. It says guess. I hit enter again. It tells me this intersection is 5.77. Okay, 5.78. Okay. Now, what is the domain of H? The domain is the x values that work. So we can start at 0 and we go to 5.78. That's my domain. Notice it's only one mark, and notice it says write down. There's no work to be shown. You just write down the answer. Okay, now we want to find the range. So I need to figure out the maximum. Okay, so I'm going to, so in order to figure out the maximum, I've got my equation already typed in here, as we saw, and I've already changed my window. And so to find out our range, I need to figure out the maximum. So I'm going to hit second trace. This time I'm going to go choose 4 to do maximum. And then left bound, I'm going to go to the left of the orange dot. So I need to hit this left arrow to get the left side of the peak. Okay, so the peak is right here where my pen is pointing. You can see my blinking X is to the left of the peak. I hit enter. Now it says right bound. I'm going to hit this right arrow until I'm on the right side of where my pen is pointing. I hit enter. It says guess. I hit enter, and it tells me my maximum point is 2.86, comma 41.48. So my range is the y values, right? So the lowest point is 0, and the highest point is 41.5. Okay, might want to hit pause if you need to copy down these details. Okay, question 3. Okay, so we're going to make a few trapezoids here. Okay, so starting at 0, so here's a trapezoid, here's a trapezoid, here's a trapezoid, and here's a trapezoid. Okay, so I've got 4 different trapezoids. And from my formula equation, from my formula packet, I think it's on the last page, second to last page. So the trapezoid rule says 1/2 h y0 plus yn. Okay, so my y0 has a height here of 2. My yn here has a height of 148. That's this length here and this length here. And 2 parentheses y1 plus y2 and all those. So all of the heights of these different trapezoids in here. Now, one of the mistakes that I almost made when I was making my answer key is this parentheses here and this parentheses here. If you don't have those parentheses, I almost didn't multiply the h times the whole thing. I almost only multiplied it times this. So be careful with your parentheses. You don't want to make the mistake that I almost made when I was making my key. Notice I scratched this out. Okay, so these other heights here are 5, 15, 47. So 5, 15, 47, these blue heights here. Okay, and the yellow heights here are the ones, the bookends of our trapezoids here. Okay, and the distance from here to here, the distance between each of these height things, you can see it keeps increasing by 1.1. Okay, so if I add the yellow values together, then plus 2 times our blue values, we get this. And then, so 1/2 times 1.1 times the 150 plus 2 times 67 gives me 284, and then we get this area here. Okay. Now, it's been found that here's the equation. So write down the expression of the antiderivative. So we started at 0. We ended at 4.4. So my integral starts, lower boundary is 0, upper bound is 4.4. Write the function, write dx. That's it. Okay. Now, this is too crazy to do fundamental theorem of calculus. I'm just going to ask you to do this using your calculator. So you hit y equals, you type in this stuff, second trace, you get function, your lower boundary is 0, your upper boundary is 4.4, you should get this area. When I graphed it, it kind of came off the screen. So you need to make sure that the top of the screen has the graph, otherwise you may get an error. What I did when I did this, let's do this one because I think you should see what happened to me. So if I do 3.88 x cubed minus 12.8 x squared plus 14.1 x plus 1.54. What am I doing? Let's type that over again. 3.88 x cubed minus 12.8 x squared plus 14.1 x plus 1.54. And if you graph that, it before I get to 4.4, it comes off the screen. But if I do second graph, I can see a table, and I know I need to get higher than my upper boundary of 4.4. So if I go to 5, my upper boundary is 237. So what I did by doing second graph to get the table here, this tells me where the upper part of my window should be. So second graph got me the table, and then I need to make the y max like 300, just something bigger than 237. So I made when I changed my window, I had my y max that helped me figure out the y max should be 300. And then when you go through the second trace, lower boundary, upper boundary, you should get this answer. Okay, so now it says find the error. So this formula here is in your formula packet. Um, Here it is. In topic 1, down here. So VA is the approximate value, VE is the exact value, and so you're going to be using this formula. So here I've rewritten it just to make it simple for you. So the exact value is, no, sorry, the uh, okay, so I accidentally switched these two, but you're still going to get the same answer if if these two are switched, because it's absolute value anyways. It should have been 156.2 minus 143 divided by 143. This is the exact. This is the exact. So I switched these two on the paper by accident. Let me just rewrite it correctly. It should have been the approximate, which is 156.2 minus 143.4 divided by 143.4. Like I said, you're still going to get the same answer, because this minus this is going to give me 12.8 over 143.4, which is still going to give me this answer that I got up here. Okay, so this is the approximate value minus the exact answer divided by the exact answer. Okay, then I end up with 8.93% error. Okay. Okay, it's already in vertex form. What is the vertex? It's 1, 5. Okay, they want you to graph this. So if I'm graphing this already in vertex form, I know my vertex is 1, 5. Go right there. I go over 1, down 1, over 2 from the vertex, down 4, over 3 from the vertex, down 9. Okay, there's my graph. Okay. Find the area of the region enclosed by x equals -1, 2, and f of x, and the x-axis. So basically from -1 to 2, and that function there for f is x squared. Okay. And then find the integral from -1 to 2. So here's my function g. I used my calculator, second trace, lower boundary, upper boundary, lower boundary, upper boundary. And then to find the area shaded, I did the function g, which is on top, minus function f. Okay. Last question. No, almost not quite there yet. Okay. So they told you to find the derivative of this. We get this. The derivative of that gives me this. Okay, find the maximum height of the tunnel. So you know that the height is going to happen when the derivative is 0. But this is not the answer. After I get the answer, I need to plug 10 into my function, and then that will give me this height. I could also do left bound, right bound, and figure out this height as well. Okay, find the height of the tunnel when x is 9. So I'm using this equation, and I'm going to plug in 9 in place of x. I'm going to use the same equation and plug in 12 in place of x, right? I could 9 equal y equals negative 0.05 12 cubed plus 0.8 12 squared minus 8.5. So I plug in 12 in for x, and then we get this answer. Then I use my trapezoid formula, and we get this. Write down the integral. So the beginning lower boundary is 6, upper boundary is 15. And find the cross-sectional area of, basically they wanted you to type this into the calculator. So, okay, last one. Okay, last page. Okay, so determine the profit if it's increasing or decreasing. They've given you the rate formula, so it's the derivative. So when t equals 2, I plug 2 in place of t, and I end up with negative 4. So since this is a negative value, that means it is decreasing. Okay, 1 year after the company was founded, the profit was $4,000. Find the function. So I've got my integral symbol. My derivative is 3t squared minus 8t, and I take the antiderivative of that. So this power increases, it becomes cubed, and 1/3 times 3, just the coefficient goes away. This power increases, it becomes 2, and so since this is 2, we have to multiply the coefficient by 1/2. So that's why this becomes 4. And then we put our plus c, and now we're going to solve for c, because when t is equal to 1, because it's after 1 year, we know that the profit is going to be 4. So $4,000. So the profit's going to be 4. So I'm going to replace this with 4. I'm going to replace t with 1, and now we can solve for t. So I get 4 equals 1 minus 4, and 1 minus 4 is negative 3. Add 3 on both sides, I end up with c equals 7. Okay, last question. You've got this picture here. And you know this coordinate is negative 1, comma negative 1. This coordinate is 2, comma 2. Use the trapezoid rule to find the approximate area. So to find the approximate area, well, we need to, we already know these heights, they were given to us. This height here is 1.6. The final height there is 0. And the heights of the blue lines is 1.2 and 1.2. Okay. So using our trapezoid formula, so 1/2 h, so h is the width of each trapezoid. There's 3 trapezoids here. So the width from here to here is 1. And then the initial height and the final height, that's what we have here in our formula, our initial height and our final height. And then these other heights are the heights in the interior of our trapezoid. Okay. We've only got 3 trapezoids. Okay. So put it into our trapezoid rule formula, and we end up with the area of the trapezoids being this. Now, they want you to find the exact area, so I use my calculator. I rewrote the integral from negative 1 to 2. I wrote the function here. Now, super important, in order to have all of this divided by 10, you've got to put some parentheses here, and then divide by 10. Okay. So second trace integral, lower boundary negative 1, upper boundary 2, and you get your area. Now find the area of the unshaded region. So I need to figure out the area of the square minus the area shaded, and that will give me this area, the white area that's not shaded. So the area of the square from here to here is 3, and here to here is 3. So my area of my square is 9 units. The area of the shaded region we just figured out was 2.92 units. So I subtract and that gives me the area unshaded. I hope this helps.